Every time you flip a light switch, you're placing your trust in this gigantic, continent spanning machine to work flawlessly. But what happens when it doesn't? Well, lurking behind the scenes is this incredible, unseen system, a silent army of guardians that stands ready every single millisecond to stop a catastrophic failure in its tracks. Today, we're going to pull back that curtain and look at the amazing history of how we keep the lights on.
So, here's our game plan. We'll kick things off by understanding the enemy, that critical moment of crisis on the grid. Then we'll meet our heroes, a powerful duo known as the Brain and the Brawn. From there, we'll jump back in time to see where they came from as these clever mechanical guardians. We'll watch them evolve into electronic wonders and finally see how they became the digital superheroes of today's smart grid. All right, let's set the scene. I want you to imagine our entire power grid as this perfectly balanced, tightly stretched web. It's just humming with energy. But the thing is, that web is constantly under attack from, well, pretty much everything. Nature, people, you name it.
So, what actually happens in those moments? It seems like a simple question, right? But the answer is really complex. When something goes wrong out there, a lightning bolt hits, a branch falls, it triggers an emergency. And we're not talking about a small hiccup here. This is an event that can unleash an absolutely incredible amount of destructive energy. That event has a name. It's called a power system fault. The easiest way to think about it is as a colossal short circuit. All that electricity, instead of going where it's supposed to, suddenly takes a violent shortcut. This unleashes a massive surge of current that can literally melt equipment, and if it's not stopped in a fraction of a second, it can cause a domino effect that takes out an entire region.
So how in the world do you fight a disaster that's over and done with in milliseconds? Well, you need a system that's even faster. And for the better part of a century, the solution has been this brilliant partnership between two kinds of devices, one acting as the brain and the other as the brawn. Okay, so the brain of the operation, that's the protective relay. It's the lookout. It's the detective. Its only job is to constantly watch the flow of power, looking for that huge abnormal current that screams fault. The instant it sees a problem, it makes a decision and sends a command to its partner, the brawn, the circuit breaker. The breaker is just pure muscle. It's a heavy-duty switch that gets the order and physically throws the switch open, stopping that destructive power dead in its tracks. And all of this happens with just breathtaking speed. So, boom, a fault occurs. The relay sees that massive surge instantly. It fires off a trip signal to the breaker. The breaker's contacts fly open, and that faulty piece of the grid is completely cut off from everything else. The really crucial thing to get here is that this whole dance, from the moment the fault happens to when it's isolated, has to be over in the blink of an eye. It's the only way to save the rest of the grid. But these guardians, they weren't always the high-tech gadgets we think of today. Let's actually travel back to the early days of electricity, to an era of just pure mechanical genius. Way before transistors or microchips were even a dream, we had the electromechanical relay. And honestly, these things are masterpieces of engineering. They had zero electronics inside them. Instead, they used the raw physical force of the fault current itself, basic electromagnetism, to physically move gears and springs and levers to get the job done. And the way they worked was just so elegant. In one of the most common designs, the induction disk relay, that huge fault current would rush through a coil, creating a powerful magnetic field. That field would then make a little metal disc nearby start to spin, kind of like a tiny motor. As that disc spun, it would physically push a set of contacts together, completing a totally separate circuit that then told the breaker to open up. It's just pure physics in motion, using the problem to power the solution. For decades, these mechanical marvels were the grid's front line of defense. But, technology never stands still. The invention of the transistor was about to kick off a brand new era for grid protection, the electronic age. The new champions on the scene were called static relays, and they were a total game changer. They were called static because they had no moving parts, zero. Instead of spinning disks and clicking levers, they used electronic circuits with transistors and diodes to do all the sensing. And the difference was night and day. They were unbelievably fast. We're talking milliseconds fast. And with no mechanical parts to wear out, they were way more reliable and needed a lot less maintenance. Now, that jump to solid state was a revolution for sure, but an even bigger one was right around the corner. The very same technology that was putting personal computers in our homes was about to completely transform the grid's immune system. Protection was going digital. Meet the modern Guardian, the numerical relay. At its heart, it's a small, tough, super fast computer, and it has one single purpose: to watch that power line. It's taking thousands of digital snapshots of the voltage and current every single second, running all that data through complex algorithms and looking for the tiniest hint of a fault. Then it makes an intelligent call on whether to trip the breaker. And the advantages here are just immense. I mean, a single numerical relay can do the job of an entire wall of those old mechanical ones. They're also constantly running self-checks on their own health, which makes them incredibly reliable. But maybe the biggest deal is that they're based on software. So if the grid changes, engineers can just update the code instead of ripping out hardware. All this digital brainpower gives us a level of accuracy and performance that was just science fiction a few decades ago. So when you step back and look at the whole story, it's just this incredible journey of evolution. We've gone from cogs and coils to circuits and code. The guardians of our grid just kept getting smarter, faster, and stronger to keep up with the demands of our world.
You can really break it down into three distinct eras. First, you have that foundational age of electromechanical relays, using just clever physics. Then came the solid-state revolution, with static relays, bringing that incredible speed and reliability. And that leads us to today, the era of digital intelligence, with numerical relays powering the smart, resilient grid we all depend on.
You know, this quote here really says it all. This whole evolution wasn't just about making cooler technology, it was an absolute necessity. As our society demanded more and more from the power grid, as it got more complex, the protection systems had to evolve with it. The speed and the intelligence of today's microprocessor-based relays are what make reliable power possible. But this story is far from finished. The grid is changing faster now than ever before. We're integrating renewable energy like solar and wind. We've got the rise of electric vehicles, the potential of AI. All of this creates brand new challenges for the grid. And that leaves us with one final big question to think about. What will the next generation of these guardians look like? How will they evolve to protect the even more complex power system of tomorrow?